As with all number systems, the African number system derived from the people's needs within their communities. The names of numbers are related to the numbers they counted in their daily work in agriculture and on farms, where they had to keep track of herds of animals. They also used gesture counting in their local markets where people who spoke various languages traded merchandise. As currency and as counting tools, they used pebbles, cowrie shells, nuts, and beads. The use of cowrie shells led to the development of more complicated number systems. The building and selling of goods led to an accepted use of weights as well as other measuring forms. A sharp sense of observation, numbers, and geometry were extremely valuable traits which they employed in their day-to-day lives. They were also able to distinguish their livestock from each other based on their horns and on their patterns. The patterns they used in designing their crafts had special meaning. They invented a plethora of games that involved intricate number patterns. They also used magic squares. In a magic square of 15, the numbers in each row or column add up to 15. Some used these as a form of numerology or for astrological purposes. The contributions that Africans have made to the mathematics are extensive. For instance, the earliest known counting system that has been discovered is a carved bone that was found in Zaire in a fishing site in Ashango on Lake Edward. This bone has notches that are arranged in patterns and is estimated to be from the period of 23,000 BC to 18,000 BC. The first group of markings shows the use of prime numbers between 10 and 20. The second group shows a pattern of 10 plus 1, 20 plus 1, 20 minus 1, and 10 minus 1. The third group shows a pattern of doubling numbers. Others believe that the markings are associated with lunar periods. Ancient Egyptians devised methods of weighing and measuring that utilized mathematical operations that were recorded on papyri, a material prepared in ancient Egypt from the pythia stem of a water plant used as sheets. The following early African measuring and counting systems may be found in Africa Counts: Number and Patterns in African Culture by Claudia Zaslavsky. Cowries are still used today in many parts of Africa. Africans find it beneficial to count and solve arithmetic problems by using piles of stone. When counting, they use a set of symbols and number words or gestures that replace words. Most Africans adopted a base 5 quinary numerical system, while some adopted a base 10 or a base 20 system. In Zulu, the 6 means take the thumb. Once you have used all of the fingers of one hand and must move on to the use of your thumb on your second hand. The words for 1, 6, 7, 8, and 9 vary throughout Africa. 2 is li or d, 3 is ta or sa, 4 is ne, 5 has many versions of the word hand. Another extraordinary African counting system that is used by the Yoruba peoples use, who use a complex vigesimal system that includes addition, subtraction, and multiplication. Zabloski also pictures the following hand gestures of the Taita and Kamba peoples of Africa. Since the Yoruban people gained their independence from Europe, they have been working towards expanding their native vocabulary. This is also true for many other parts of Africa. The Hindu-Arabic number system that is used worldwide today originated around 500 AD in India. The system includes numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, but with the addition of the number 0, one could create infinite numbers. The Hindu-Arabic number system eventually made its way to the Arabs in the West, and then to North Africa. During the Middle Ages, the Hindu-Arabic number system made its way to Europe and then spread throughout the rest of the world. Musa al-Khwarizmi, known as the father of algebra, adopted the idea of 0 as a number and was responsible for bringing the Hindu-Arabic system to the rest of the world. The Hindu-Arabic number system stemmed from the use of counting with fingers on both hands, which is how the base 10 system was formed. If one wanted to express the number 54,328 in base 10, one would use the following computation. The all-important 0. 0 is not only a concept of nothingness, which allows us to do arithmetic efficiently, but it is also a place-holding device that enables our base 10 number system to work, so that the same 10 numerals can be used at different positions in a number, making our system extremely efficient. The creation of the Hindu-Arabic number system changed the world by allowing Indian astronomers and scientists to develop at a more rapid pace than their counterparts in other countries. This system opened the door to all things mathematics that we see today, including algorithms currently used by Silicon Valley. The Mayans developed a base 20 number system around the year 1000 BC. Mayan records were destroyed mostly due to the colonization of the Spaniards. It is said that they derived the system from using their fingers and toes. The Mayans used a base 20 vigesimal system composed of the following symbols: 1 dot for the number 1, 1 bar for the number 5, a shell to represent 0. They wrote their numbers vertically. The 0 allowed them to create a system that includes place value. You can only place up to 19 items in each place value in the Mayan number system. To express the base 10 number 5,555 in base 20, we complete the following steps. Evolution of the Mayan number system. In addition to the base 20 number system, the Mayans developed a written system that predates the Colombian Americans, developed a calendar system, and a hieroglyphic writing system. They also had tremendous achievements in astronomy, mathematics, the arts, architecture, and science. Our present Hindu-Arabic numeric decimal base 10 system came into widespread use because it made it much easier to write large numbers only using the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, whereas the older systems used too many symbols that made that process much more difficult. The number 0 also had a great deal to do with moving to the Hindu-Arabic system because it allowed 0 to be used as a value and as a placeholder. The introduction of 0 into the decimal system in the 13th century was the most significant achievement in the development of a number system in which calculation of large numbers became feasible, which is one of the main reasons people eventually moved away from the earlier numeral systems.